right, so this is the next section of chapter 3. It is on stress and strain. So, stress is a force on, well, anything, but in this case, we're thinking force on rocks. And strain is the result of stress. So, if it changes shape somehow based on that force. So, there are different types of stresses. There's compressive stress. This is when it's like pushing something together. This is squeezing or compressing it. There's tensile stress, which is pulling it or stretching it. And there's shearing, which says, move in different directions. But this is like if you tear a paper, that is a shearing stress. You're not pushing the paper, you're not really pulling it apart, which would tear it as well. But if you just take your hands, like one hand goes left and one hand goes right, and you tear the paper down the middle, that would be your shearing stress. And the strain, again, is the change of shape based on that force or that stress. And there are different types of strain as well. There's elastic and plastic deformation. So elastic deformation, this is if you think of your rubber band. It's usually temporary and it can jump back into shape. You pull on the rubber band and you let go, it goes back to how it was before. This is elastic. Now, if you pull too much on that rubber band, it's going to snap. That is when it has reached its elastic limit. It's a permanent, and it cannot retain its original shape after it has reached that elastic limit. So same thing with certain rocks, and how they respond is based a lot on properties of different rocks, as well as depth, their temperature and things that we'll get into a little bit later. If you think of, glass definitely is not elastic, but if you heat it up, you can mold it. Same thing with rocks. So if you heat up a rock, it can become more elastic. And so the opposite of elastic is plastic deformation. Now, this is what we see most commonly in rocks. And this is once the elastic limit has been exceeded, you get the permanent changes. So what do those changes look like? It can either be brittle or ductile. So brittle is like if you think of a chip, like a potato chip. You can't really bend that potato chip. You do pretty much anything to that potato chip and it is going to break. That is brittle. Ductile is more like what we would think of like metals or plastic. You can really take a hammer to your car and you're going to really dent it, but you haven't broken it. There's not actually like a break. It's just dented. That is your ductile deformation. And so here are some images of that. So here are like our car dents in rock. We call these folds. And so you can see this at one point in time, this was straight, but it has been deformed. And we see these folds here. Same thing with these on a much smaller scale. And if it's brittle, it will break, and that is what we call a fault. And you can see the two faults in these images here, right here. Well, actually, there's quite a few of them, but this is probably the main one. And then right here as well, where you can see the fault. And that is it for stress and strain.